Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. The 2014 question on probability, this was question 1 from paper 2. Two different games of chance shown below can be played at a charity fundraiser. In each game, the player spins an arrow on a wheel and wins the amount shown on the sector that the arrow stops in. Each game is fair in that the arrow is just as likely to stop in one sector as in any other sector on the wheel. Part A. John played game A 4 times and tells us that he won a total of €8. In how many different ways could he have done this? Okay, they spin the wheel and they win the amount shown on the sector. So €8. Okay, so if I zoom in there on game A, €8 can be only made up from the 5 and the 3, isn't it? Okay. Yeah, 0 and 0 will be nothing. 6, there's no €2 to go along with the 6, so just the 5 and the 3. Okay, so if he's going to win and he has 4 times, the only way he could do it is to get a 5, a 3, a 0, and a 0. So that would be his 4 times. Okay, and then it's all the different combinations of that. And I'm trying to think if there's any clever way of doing it, any mathematical way. I don't think there is, though. I think you just have to write them all out. So let's move this 5 along. Okay. Swap the 3 and the 5. Okay, that's what I think it is. Okay, so what I'm writing out here is what's called the sample space, okay? It's the set of all possible outcomes. So I make it 12 ways. Okay, so part B then. To spin either arrow once, the player pays €3. Which game of chance would you expect to be more successful in raising funds for the charity? Okay, raising funds for the charity. So you want to be paying out the least amount. So watch that one. Watch to see is the question from the point of view of the gamer or from the point of view of whoever's hosting the game. So this is from whoever's hosting the game. It's from the point of view of the charity. So to spin either arrow once, the player pays €3. Which game of chance would you expect to be more successful? Okay, the reason I underlined the word expect is because to figure out your chance of winning or on average, how much would you win? It's all about the expected value. And there's a formula for that, which is the sum of the X values, which so in this case, it's how much you could win multiplied by the probability of you winning them. Okay, so that's the formula for expected value. So these are all the different values you could get, and this is the probability of getting them, and this sigma symbol is add them all up. Okay, so if we were to do game A, it would be I could win €5. I'm starting there up here at the top. So I could win €5 and the probability of me winning €5. So remember they said that the probability of stopping in each sector was the same. Okay, yeah, it was just as likely to stop in one sector as the other. So 1, 2, 3, 4, 5 sectors. So I have a 1 in 5 chance of winning that €5. The next one is 0. And I could go 1/5, or I could go 2/5 and combine these two together. In other words, I have 2 chances of winning, 2 in 5 chances of winning 0. I have a 1 in 5 chance of winning the €6, and I have a 1 in 5 chance of winning the €3. Okay, and that's what you put into your calculator. And for that, I'm just going to put it into my calculator there. It is 2 and 4/5 is what I'm getting, or 2.8. Okay, we switch color there now, and let's work out game B. Right, so I have, let's start up here around the €2 spot again, and I have 1, 2, 3, 4, 5, 6 divisions on this one. So to win that €2, I have a 1 in 6 chance. To win the €5 beside it, I'm just going around clockwise. 5, I have a 1 in 6 chance. To win 0, I have a 1 in 6 chance. The €3, 1 in 6. The €1, 1 in 6. And the €4, 1 in 6. So again, put that into the calculator. And I'm getting 5/2, or 2.5 for that one. Okay, so in English, what does that mean? What have I just worked out? Well, it means statistically, on average, that is the amount that game B will pay out. Okay, and obviously it's not a value on the actual wheel. Okay, so that's not what expected value is really. You might say, for example, game A, it's more easier to see it. You might say that the expected value on game A might be 0 because it appears twice. Okay, so it's not that. It's not a logical way of thinking about it and see, well, what is the most likely one to happen. It is a calculated one on statistic, I suppose, on average, what does that wheel pay out? So yes, it will pay out to a lot of people. It'll pay out €0. To a lot more people, it'll pay out 5 and 6. Okay, so if we were to sum up over a long period of time all the monies that wheel pays out, and I suppose doesn't pay out, you would find that on average it pays out €2.80. Okay, and the same with game B. Over a long length of time, on average, that wheel would pay out €2.50. Okay, because it's mixed between the small numbers, the 0, 1, 2, and 3, and of course the 4 and the 5. Okay, so which one is better from the charity point of view? Well, from the charity point of view, it is game B, because it pays out less. Okay, so if it costs €3 to enter this game, then on average, for every single game that's played, game B would make a profit of 50 cents. Game A would only make a profit of 20 cents. Okay, so the answer to that one is game B. Give a reason for you. It pays out less on average. Okay, or something like that, or the expected value is less. Okay. Mary plays game B 6 times. Find the probability that the arrow stops in the €4 sector exactly twice. Okay, so when I see this exactly twice business, I'm always thinking of a Bernoulli trial. Okay. And I'm asking myself, is this a Bernoulli trial? Because if it is, then I can use the formula that goes with that. So for it to be a Bernoulli trial, I need to have a success and a failure. Okay, so a success in this case would be the €4 sector, okay, because that's what we're measuring. And the failure is not €4. Okay, is the probability of success the same for each event? Yes. So every time you spin it, you have a 1 in 6 chance of getting a 4. So in that essence, the probability is the same. Is it a set number of trials? Yes, it is, because we're only going to do it 6 times. And then is it independent? Well, yes. If I get a few €4 on this spin, that has no bearing on whether I'll get 4 on the next spin or not. So yes to the Bernoulli trials. Okay, so then the formula. Well, you're playing it 6 times. So out of the 6 times, I want 2 successes. Okay, so what does that mean? Where did I pull all those numbers for? Well, this 6 is the amount of trials that I have. I said my success was €4 and I want 2 of them. So that's that 2 that's there. So out of the 6 trials, I want 2 successes. The next part is the probability of success. I want 2 of them. Okay, so this number came from the probability of getting a 4. And remember, we said the probability of getting a 4 is 1 over 6. So I have 1 chance in 6 of that spinner landing on the €4. And I need 2 of these if I'm going to get exactly twice on the €4 sector, which means the probability of not getting a 6, I need 4 of them. Okay, remember, probability always adds up to 1. So if the probability of getting a 4 is 1 over 6, then the probability of getting not 4 is 1 minus that 1 over 6. And that's where I pulled my 5 over 6 from. Okay, and I need 4 of them. So what you'll notice is my 2 successes and my 4 failures have to add up to the amount of trials that I have. Okay, and then this number will always match this one. And you put that into your calculator. So 6, 2 over here is 6 choose 2. We need that because I'll just put it into the calculator and then I'll explain to you why we have to have that in it. Need 4 of them. Okay, so I'm getting 3125 over 15552. So as a decimal, I'm going to STD that, it's 0.2. So a 20% chance that it lands exactly twice. Okay, so what is this 6 choose 2 business about? Okay, well, that takes care of all the different ways Mary can play the game and get €4 exactly twice. So in other words, we could get the 4s first, and then I'll go not 4, not 4, not 4, not 4. Okay, and there's my 6 events, 1, 2, 3, 4, 5, 6. Of course, I could get a not 4, a not 4, a 4, a 4, a not 4, a not 4. I could get a not 4, a 4, a not 4, a 4, a not 4, a not 4, and so on. So if I put into my calculator 6 choose 2, I'm getting 15. So in fact, there's 15 ways that we can write out options of how Mary would get the €4 exactly twice out of those 6 games. But thankfully, we don't have to write them out and think of them all. 6 choose 2 takes care of it for us. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.